So in the previous lesson, we were dealing with polynomials, but we were adding and subtracting. We talked a little bit about the degree of a monomial, the degree of a polynomial. In this part of chapter 8, we're multiplying. So we'll take a monomial and we will distribute, right? We talked about distribution. We did a little bit of it in chapter 7, if you remember. And here we go again. We're going to do some of those same things, except we're adding some small pieces here and there. The other thing that we'll do today is we'll solve equations with products of monomials and polynomials. So an equation simply says we're going to have an equal sign, right? We'll have an equal sign. We'll have expressions on either side of that equal sign. And so the process of solving an equation is simply going to say, let's simplify the left side of the equal sign. Let's simplify the right side of the equal sign. And then once we get to a place where everything is as simplified as it can be, then we'll start moving algebraically from one side of the equal sign to the other, using those inverse operations, right? So here's our first one, multiplying a polynomial by a monomial. I'm going to do this the long way, just so you can see how all of the parts are moving. But what's basically happening here is this 3x squared, negative 3x squared, wants to get distributed, right? There's an understood kind of multiplication sign there between the variable and the parenthesis. And so we want to distribute, we want to multiply. So the negative 3x squared wants to be multiplied times the 7x squared, and it wants to be multiplied times the negative x, and it wants to be multiplied times the positive 4. And so in kind of an extended version of what that looks like, the negative 3x squared wants to be multiplied times 7x squared. And then the negative 3x squared wants to be multiplied times the, and I'm going to group it here because we're going to lose our symbols if we don't, wants to be multiplied by the negative x. And then the negative 3x squared wants to be multiplied times the 4, right? Now all of these are things that we've done before. We've handled this before, right? Where the negative 3 times the 7 is negative 21, and the x squared times the x squared is x to the 4th, right? And then this piece here where the negative 3x is being multiplied times the negative x. So a negative times a negative, remember, is a positive. And I hear some of you thinking already, that's not a negative, that's a subtraction. Well, subtracting 3, multiplying times a negative 3, like these are very similar things that are happening here. And then the x times the x would be x cubed, right? Adding those exponents, right? So negative 3 times the negative 1 that's sitting there would be the positive 3. X squared times x would be x cubed. And then this very last one, right? Negative 3 times 4 would leave us with a negative 12. There's nothing to multiply times the x squared, and so it's just x squared. If anything was like, and we've talked about or will talk about like terms, if any variable and exponent combinations were the same, we would combine those terms. As it stands, nothing can be combined, and it's already in standard form. So that's another one of those things that we'll want to make sure we're trying to pick up. Once we get introduced to standard form, we'll make sure that we're putting things in standard form, and you'll know what that means when we get there. But this would be your final answer. The negative 3x squared was distributed into the parentheses and was multiplied by each of those pieces. Okay? Now, this one is a little different. Notice what's happening here. We've got two sets of parentheses, and for all practical purposes, the 2p only wants to get into this parenthesis, and the negative 5 here wants to get into this parenthesis. So there are two kind of simplification processes that would happen. And then again, when we get done, and we'll talk about like terms, but when we get through distributing, if there were like terms, we would put things together. So let's take the 2p times the negative 4p squared. 2 times negative 4 would be negative 8. P times p squared would be p cubed. Okay. 2 times a positive 5 would be a positive 10. And p times p would be p squared. And then that first set of parentheses there is simplified. Right? There's nothing else to do inside the parentheses. Nothing else is trying to multiply its way in, or there's no exponents to deal with. So let's move on here, and let's take the negative 5 and let's distribute it. So negative 5 times 2 would be negative 10p squared. And negative 5 times 20 would be negative 100. Okay. If there are terms the same, p squared, p squared. If there are terms the same, then they can be combined. And it won't work out this way every time, but in this case, the plus 10 and the minus 10 would cancel, and so that those p squared terms would go away. They would cancel each other out. And so negative 8p cubed minus 100 should be your final answer for this one. Okay. Now this one's a little larger, but we're still talking about a set of parentheses here that something is trying to be distributed into, and another parenthesis that something's trying to be distributed into. So pause the video, you work this one out, and then check your answer against mine when we're done. So here we go. 3 times 5 is 15x squared, plus 3 times 2 is 6x. 3 times negative 4 is negative 12. Okay, and then that's the first parenthesis fully simplified. All right, now the negative x, let's distribute it. Okay, negative 7x cubed, negative 2x squared. Let's pause and let's make sure you understand why both of those are negative. That is a negative x that is being distributed. So a negative times a positive gives me a negative. A negative times a positive is a negative. And now here, a negative times a negative would be a positive 3x. Okay. Now, this is a really long expression. There's probably some things that can go together that can be combined here. So as we look through here, I see the largest degree there is 3, and so we'll go ahead and get negative x cubed up there front. There's a couple of x squareds. Okay, so that one would be next, and the 15 minus the 2 would be plus 13x squared. I see a couple of x's here, 6x and 3x combined would give me a 9x. And then let's not forget the 12 minus 12. And that would be your final answer. Okay. Again, we distributed and then we collected terms. The things that matched, exponent, variable, we put together, we combined them. Okay. So this is where we go from there. And solving an equation, and I mentioned this in the intro, let's do everything we can on the left-hand side of the equal sign. Let's do everything we can on the right side of the equal sign. And then we'll start moving things around algebraically. Okay, so distribution on the left, 2x times x, 2x squared, 2x times 4, positive 8x. The 7 is outside the parentheses, so nothing happens to it. All right, so 2x squared plus 8x plus 7 equals, and then everything on the left side of this equation is simplified. Nothing else can be combined. Nothing else needs to be distributed. Okay, so let's move on to the right-hand side. X plus 8. There's a parenthesis, and if we could do anything with that parenthesis, we would. There's no exponent. There's nothing that wants to be distributed. X and 8 can't go together, So that parenthesis is already simplified, and so the parentheses can go away. Okay, we did the parentheses. There was nothing that we could do. Okay, this next one, there is something we can do. That 2x wants to be distributed. 2x squared plus 2x, and there we have that distributed. And then there's a plus 9 hanging out back there. Now we've already said that everything here on the left was fully simplified, but everything on the right is not fully simplified. So let's drop us another equal sign here. And let's go ahead in standard form. Let's collect our like terms. So there are no other x squareds. So there's our 2x squared. Okay. There are several x terms. And so x plus 2x is 3x's. And then the 8 plus 9 is 17. Okay, let's drop the other side of the equation down. Fully simplified on both sides. Now let's start moving the things around to try to get x by itself. Now you might remember this from maybe chapter 4, chapter 5. Let's go ahead and subtract 2x squared from both sides, right? And so this works out well for us because we don't really know how to handle squared terms yet, but those squared terms cancel themselves out. So 8x plus 7 equals 3x plus 17. Subtracting 3x from both sides, subtracting 7 from both sides, and 5x equals 10. Dividing both sides by 5, and x equals 2. Okay. Now this is one of those things where, and I won't do it here, but you can take that x equals 2 and go right back up here to the original equation and plug it in, follow your order of operations, and you should get a true statement, right? What's on the left should equal what's on the right when x equals 2. Okay, solving the equation. Now these equations will get more complicated in the sense that they will get a little longer. There'll be more distribution. There'll be more terms to combine, to collect together. But this is the basic idea behind multiplying a polynomial by a monomial.